Okay, hello everyone, and welcome back. Today we're going to end our unit here before the test later this week by comparing, all right, three different types of functions. We've been looking at quadratics only, but it's important to know, okay, what is the difference between a quadratic and other types of functions? In this case, we're going to look at linear and exponential. Now, we've looked a lot at linear before, and you know what an exponential is too as well, but we'll review both. All right, again, today's objective, to identify a function as linear, quadratic, or exponential. Right. Our essential question, and you're going to need that for the notes assignment. How can we determine the type of function from a table or a graph? Guys, the exit ticket today is all about tables. It's a little harder to do from a table. It's a little easier from a graph, okay? Now, just to kind of review, remember, guys, a linear function, it has a constant rate of change. It has a constant slope. This graph is a straight line. And you remember, y equals mx plus b, where b is the y-intercept and the m is the slope, okay? As a quadratic, that's what we've been looking at. It is a constantly changing rate of change. In other words, the rate of change, it's changing, but it's changing at a constant rate. And we've expressed a quadratic in three different ways, okay? Standard form, vertex form, and factored form. All right, that's these three right here. As the graph is symmetric and shaped like a U. Again, you've seen it before, or an upside down U, okay? This exponential is a little different. It's where the variable x is the exponent. All right, it's up in the exponent. The rate of change, it increases by equal factors as x increases. All right, the graph, it grows and shrinks rapidly. That's what exponential does, okay? Now, a table of values. This is kind of the hard part, okay? You're going to get tables of values, and I'm going to do these in the next video, and they're going to be the exit ticket here today. You're going to get x and y values. First, just make sure that the x values go up by 1, and then look at the y values. You have to try to determine, is this linear, is it a quadratic, or is it exponential? All right, the way to tell if it's linear is the first differences. And I start at the top with the largest number of y, which is 7. 7 minus 5, that's 2. 5 minus 3, that's 2. 3 minus 1, that's 2, okay? And 1 minus negative 1, yes, that's also 2, all right? When the first differences are a constant, they're all the same number like that, 2, 2, 2, 2, then this function is linear. That's what that means, okay? All right, if you get a table, and again, you check the x's. They each go up by 1. That's what you want. What's the deal with the y's? Again, let's look at the first difference. You take 51 minus 33. Then you take 33 minus 19. And 19 minus 9. And then 9 minus 3. Okay, you write them down, and it's like, uh-oh, those aren't the same numbers. We'll do it again. It's called the second differences. Do it again. Take the answers that you just got. Take the differences that you just got. There's 4 of them here. And do it again. 18 minus 14, that's 4. And 14 minus 10, that's 4. And 10 minus 6, that's 4, okay? So in this case, the second differences are constant. That means it's a quadratic. All right? Number 3. As you can look at these, look at the y's. Again, x goes up by 1. Look at the y's. The y's doubles each time. 2, 4, 8, 16. All right? Guys, so the first differences and even the second differences, they're not telling us much. Guys, what you need to do is look at the ratio. The ratio over here, okay? You're going to start with the big number. 16 divided by 8 is 2. 8 divided by 4 is 2. 4 divided by 2 is 2. 2 divided by 1, okay? A ratio of the consecutive y values. If they're all the same, then it's exponential. Again, we're not looking at the difference here. We're looking at the ratio. Okay? One divided by the other, consecutive y values. Because the difference is, we tried it, it didn't really tell us much. Sometimes you don't even have to try the differences if you can just recognize that the ratios are the same. Just recognize it. Okay? Okay, guys, this is a nice summary page right here. All right, that shows the linear, the quadratic, and the exponential. In the linear, the first differences are constant. Quadratic, second differences are constant. And the exponential, the ratios of consecutive y values are constant. We have a nice example here showing what it looks like. Shows what the graphs will look like. Okay. Guys, I also want to talk about the rate of change within an interval. All right, this is a very nice, it's a thing in Desmos that I did. And look at, I'm going to call up and look at today's, this is today's materials folder. It's not published yet, okay? But if you notice, I put in a Desmos graphing calculator right here. This link, if you click on there, y'all, it will open, ooh, I gotta make this smaller. There. It will open this up so you can look at it. And again, you can, you know, like I want to get rid of the linear one, or you can always just get rid of the quadratic for a minute and just look at what those two look like and bring it back. All right? I really would like you to get to know this. Guys, what goes on? I mean, look at the difference here between what goes on between 0 and 1. And look between 1 and 2. You see how between 1 and 2, the blue actually is the one that goes up the fastest. All right? 2, 4, they all cross at 2, 4, all three of them. All right? Let me bring this up a little bit. You can see the 2. There. 2, 4, yep. And again, guys, I want you to see this blue and green. Keep following it up. Keep following it up. Keep following right there, guys. That's 416. That's another point where they meet and cross back over. This is where the green overtakes the blue. All right, where the exponential overtakes the quadratic and the exponential starts to go up the fastest. Okay, I just want you to show you that that's what happens. All right, and guys, use that Desmos graphing calculator. It's pretty cool. Again, you guys, in the interval of those 0 to 1, right here, guys, the red goes up the fastest. It has the greatest slope because it goes up 0 to 2. It has a slope of 2. Of course it does. It says right here 2x. The red is y equals 2x. All right? The blue, the quadratic, has a slope, goes from 0 to 1. Has a slope of 1 right there. And the green, exponential, it goes from 1 to 2. So it also has a slope of 1 right there. But the linear has a slope of 2. So linear, it starts off real fast. But after a while, it gets overtaken pretty quick here, okay? All right? Guys, also I want you to notice that the large values of x, like I just showed you, the green has the greatest rate of change. The green starts to go up the fastest at very large values of x, okay? And again, the graph of these functions, they intersect at different points like I showed you, but they all intersect at 2, 4, right there, all right? All right, guys, please fill out today's notes assignment and complete the summary in the green folder. And get ready for the next Zoom meeting. Please show up for it. Guys, there are 3 vocabulary questions. All right? You're just going to match the type of function with its graph, the type of function with its equation, the 3 types, again, that we talked about, and then match the type of function with the rule used to identify it from a table of values. There's a rule we talked about, okay? 3 different rules. All right, that's it, guys. Thanks.